Welcome to part 4 of the procedural Phyllotaxis tutorial by PeerPlay. In the previous part we adjusted our script to run on audio and made the lerping speed of our trail responsive to frequencies. In this part we'll continue with our script to limit the amount of iterations in the Phyllotaxis and make it repeat or stop. After that we'll implement our second function on audio, which is the scale of the Phyllotaxis. When that's all done, we'll have a quick look at creating a composition. So let's get started. Let's first of all start with removing the fixed update that we've commanded out. So we'll select everything here and remove it, clean up our script a little bit, and go to the top because we're going to add some more variables. So we're not yet doing anything with the max iteration, but what we want to do is when the max iteration has been hit, we can choose to do 3 different things. One of which is to stop everything. The other thing is to repeat the process and start at the start position again, so at iteration 0. And the third thing we want to do is to choose to go backwards. So when it hits, like for example, it'll be a max iteration of 1000. If it hit 1000, it will go back to 999, 998, and so on until it hits 0 again, then it will go up again. So for that we're going to create 3 different booleans. And the first boolean I'm going to create is a private bool. And this private bool will call forward. And if forward will be true, it will go forward. If it's false, it will go backwards. Now we'll add 2 more booleans, but these will be public booleans to set in the inspector, so we can choose whether to repeat the process, and if we want to repeat the process, if we want to invert it or not. So let's make a public bool. And we'll call this repeat, and the other one we'll call invert. Now let's use these booleans in our script. Go down to the update, and here at when the lerpos timer is above 1, we're going to do this check. So in this line we'll subtract 1 from the timer, which is done always, and the next 2 lines are the number plus and the iteration plus. But we've just created a boolean to specify whether we want to go forward or backwards. So we're going to create an if statement around these 2 lines. So if forward is true, then we're going to apply these 2 lines. And now we'll say else. So if forward is not true, and we can copy paste these lines. And instead of using plus is, we'll use minus is, and instead of plus plus, we'll use minus minus. Now the next thing we require is to check whether the current iteration is between 0 and the max iteration. So we're going to add an if statement, and if it's between these numbers, then it will set the lerp positions, and if not, then it will either repeat or invert or do nothing. So let's create another if statement. And in this if statement we're going to check if the current iteration is above 0. And we're not only checking if it's above 0, but we're also going to check if it's below the max iteration. So we're going to add another condition. And this condition says that if the current iteration is below the max iteration. Now let's put brackets around both conditions. And let's open up and close the if statement. So if this is true, then we're going to set the lerp positions. Now if this is not true, so this will be the frame where it will either have hit 0 or have hit the max iteration count. So we'll say else here, and we can comment here that the current iteration has hit 0 or max iteration. And now we're going to check if we have ticked on the repeat boolean. So we're going to add another if statement. If repeat is true, then we're going to do something, but if it's false, so if we're not repeating, it should just stop. So we can say here that is lerping is going to be false, and it will stop. Now inside this condition we have to add one more condition, and that is if we are using the invert. So if invert, if we're using it, then we're doing something, and if we're not using it, then we're doing something else. Now above here we are checking whether forward is true or false. So the only thing we have to really do here is to change forward to true if it's false, and if it's false, it should become true. So the best way to do this is to say forward is going to be exclamation mark forward. Now this statement will invert the state of the boolean. So if the boolean is true, then it's going to be the opposite of true, it's going to be false. And if it's false, it's going to be the opposite of false, and it's going to be true. Now we'll just have to call here the settler positions. Now if we're not using the invert, we're going to set everything back to its original position. So we're going to say that the number is going to be number start again. And the current iteration is going to be 0. And here we can call the settler positions again as well. And there's just one thing I skipped, and that is to go to the awake function, and we've got the forward boolean, but we've got to set the forward boolean to true at start. So we're going to say forward is going to be true. Now that should be all for this function. Let's check out in Unity what we've created and how we can apply it to our visuals. So let's save the script and go back to Unity. Now we can use the repeat and invert functions in our design. For example, let's say we want to create a trail that goes around in a circle, and after completing the circle it should go the other way. Now to make our trail move into a circle, we need to use a very low degree. Instead of 51, I'm going to specify here the degree of 2. Now we need to set our max iteration, which is now at 10,000. So we want to create one full circle, and we are going every time at 2 degrees, and a full circle is 360 degrees. So 360 divided by 2 is 180. So I can fill in here 180. So we want to use the repeat, and we're going to invert. Now let me just make the time a little bit higher to, for example, 1. And let's make for this example the lerping speed very high. So let's say its minimum is 50 and its maximum is 500. Now let's look at the result of this example. So the trail goes 360 degrees in a round, and when it hits that, it will go into its inverted direction. And it will keep looping between these points. Now that we've got the function lerping on audio ready, we can implement our second function, which is the scale on audio. This scale will have 2 different options to use. The first is directly setting the scale to the corresponding frequency amplitude. So when the frequency it listens to is loud, the scale will increase to that amount. The second option is to use an animation curve, just as we use with our positional lerping, and we can add speed to the scale lerping of the animation. These 2 options will have different interesting outputs in our visualization. So let's start adding some variables. Now let's scroll to the bottom of our list of variables, and let's add here a few new lines. And let's call these about the scaling. Now we'll start by adding some public booleans. So let's type public bool, and the first one is if we want to use the scale animation. And the second one is if we want to use the scale curve, because we make 2 different options. Now we also need a minimum and maximum scale, so just as we did with the lerping, we'll create a public vector2, and we'll call this the scale anim min max. Let's also add an animation curve, public animation curve. And we'll call this scale anim curve. Now we also need a speed, so let's type here a public float, and we'll call this the scale anim speed. Now again, we need to specify on which audio band we want to do our scale, so let's type a public integer, and we'll call this scale band. Now we'll just need to add 2 more private floats, and this is the same as we did with the lerping. We'll need a scale timer here as well. And lastly, we also need a variable in which we can write our current scale that we've calculated. Now let's scroll down to the update, and right above if use lerping, we're going to add an if statement, and we're going to say if we're using the scale animation. Now inside this if statement we're going to make a new if statement, and this will say that if we are using the scale curve or not. If we are using, do something, and if we're not using it, do something else. So if we're not using the animation curve, then we're going to directly set the current scale to the current audio band, and it will be between the minimum and maximum that we've specified in the scale and min max. So let's do that. Inside the else function we will write the current scale is going to be mathf.lerp, and we're going from one position to another position. So the start position is going to be the scale anim minmax.x, the scale anim minmax.y, and it's going to be the audio pair dot audio band, and here we are going to use the scale band that we are specifying. And that's all for the else function. Now if we are using the animation curve, we need to increase our timer. So let's say scale timer plus s, and what do we want to increase it with? We want to increase it with the scale animation speed, and it's going to be multiplied by this amount, the audio pair dot audio band, and that is going to be multiplied by the time dot delta time. Now we'll simply say that if the scale timer is higher or equal to 1, then we're going to set the scale timer minus is 1. Now we still have to apply this to the current scale, so we're going to say that current scale is going to be mathf.lerp, and we're going to lerp again from the scale anim minmax.x to the scale anim minmax.y, and here we're not going to directly set it, but we're going to look at the scale anim curve dot evaluate, and the time we want to evaluate is the scale timer. Now the only thing that's missing is that we're not really applying the current scale to anywhere, so we're going to change that. And at first we're going into awake, and we're going to say that the current scale is going to be scale. So if we're not using the scaling, the current scale will be the scale that we've set at start. Now this current scale, we're going to apply this instead of the scale in the Phyllotaxis position everywhere. So scale will be current scale, here it will be current scale as well, and let's go down, and there's another one right here, and we're going to change this as well into current scale. And that's everything there is to the scale function, so let's save the script and go back to Unity to create our visualization. I promised to show you how I made one of the trails in the Phylon visualization, so we will now try to create this visualization. Now before we're trying out our scale function, let's first go to the asset store and add the post-processing stack, because we're going to add some bloom effect. Import it into your project, and now we can add a post-processing profile. So click create and go to post-processing profile. Now go to the camera, and we're going to add the post-processing behavior. We're going to drag and drop this profile onto that. And let's go into the profile, remove the fog, and go to bloom. And I'll set the intensity to 1.5, the radius all the way up, and I'll set the threshold gamma to 0.5. Now let's have a quick look at how the scene looks with the bloom effect. I think this looks already a lot better than it was before. To speed up this video, I've already set up an example to show the difference between using the scale curve and not. So in this example, I am using a degree of 90 degrees, a scale of 0.1. We'll start at 10,000 and we'll take a step size of 1 and a max iteration of 4. Because we're going by 90 degrees, 90 times 4 is 360. So this should make a square. And when the square is done, so after 4 iterations, it will repeat and go back to 0. So we're using some lerping. And in the scale animation, we are using scale animation and the scale curve. So the scale curve has been set to a minimum of 0.1 and a maximum of 0.5. So I've set up a scale animation curve where we're going from 0 to 1, and where 1 is corresponding with the Y value of the scale and min max. We've got a scale animation speed and on which band to run this scaling. So let's check out the example with the scale curve. As you can see, with the scale curve, it's just curving from the first position to the end position and back over the animation curve. Now, if we were to remove the scale curve using, then we get the following result. And in this case, it's directly putting the scale towards the corresponding frequency of the band we've applied. So it will be a different movement and a bit more static one. Now let's have a look at how to create a fun visualization. And again, I've set some presets, and the presets I've set is the time is 0.2, the width is 0.5, we'll use this gradient, and we're going to use a degree of 2 degrees again, a scale of 0.1. I've set a semi-transparent red color here, and using a step size of 1, and we'll use a max iteration of 179. So when it's at 179, it'll be 0, and 0 is equal to 180, so it will make a full circle. Now we're using the lerping, setting the min max speed to 0 to 200, linear line, and we're using here the band of 1. Now we're going to repeat it, and we're not going to invert it. We're using scale animation, but we're not using the scale curve between 0.1 and 0.2. So let me first show it without the scale animation. So we've got just a curve that is going around and around in a perfect circle. Now if we're using the scale animation, it will scale outwards from 0.1 where it's at to 0.2 at a max. So it will scale to the current frequency of that audio band. So that will look like this. Pretty cool, right? Now we can set the time of it to a lot less, like 0.2. Now we've got one little dot going around here. Now we can increase this by adding a few more of them. So in my visualization, I've used 6 different trails, so we're going to copy paste this 5 times. 2, 3, 4, 5. And now what we can do is we can offset each one with a certain amount of degrees, so it will become a perfect circle. So as we've got 6 different trails and we've got 360 degrees around, and we're going at 2 degrees, we should increase by 30 in our number start. So this one is at 10,000. We'll set this one at 10,030. This one will be at 60. This one will be at 90. And this one will be at 120. And this one will be at 150. Now if we look at this, we'll see 6 different trails exactly at their correct positions. Now we can give them all their own color, of course. So we'll change this color to something else. Let's make it purple. Let's make this one another cool color like blue. We'll make green and yellow. And the last one we'll make something around orange. Now that we've got all these different colors, we can also specify different bands for each one of them. So let's set the first one at the lure post band will be 0, and we'll make this one 0 as well. Let's go into this one, it's already 1. We'll make this one 2. We'll make this one 3 and 4, and we'll make this one 5. Now they should all have their own color and they all react to a different audio band. Now that looks cool already, but there's one little problem because they're all reacting at a different band, so some are going at a different speed. So what I'm going to do is I'm going to select them all and I'm going to say that the speed should always be the same, so let's set it always at 200. And now they all stay in their correct distance from each other. This comes to the end of this part. There will be one more part in which we'll create a 3D tunnel out of our Phyllotaxis system. But for now I want to thank you for following this tutorial. If you learned something, hit the thumbs up or leave a comment. If you want to stay updated with new tutorials, subscribe to the channel. To support me creating these tutorials for everyone, consider becoming a patron on my Patreon, and you'll get access to all source code and project files of the tutorials.